I was surprised by the business benefits that enterprises are pursuing with SDN. Originally, when SDN emerged on the marketplace, people talked about reduced costs. And we gave that as an option to them when we were asking them, what top business benefits do you expect to experience as a result of your network transformation efforts with SDN? And reduced capital and operational expenses was at the bottom of the list of things that they're hoping to achieve. At the top is improved end user experience. This means improving the productivity of your employees and improving the experience of your customers. Number 2 on the list was revenue growth. They expect their networks to be more agile, to be able to support new business models and new applications as they emerge. They want the network to be agile enough to support those. We also saw them expecting improved customer and brand loyalty and retention as a result of SDN, which is not something you think about the network delivering to an enterprise. And finally, they hope that it improves security. Early adopters of SDN have told us that one of perhaps the most defining characteristic of the technology is programmability. The ability to program your network centrally as opposed to in a distributed fashion, as you might see with legacy network architecture. The ability to interact through a single point of programmability across your entire fabric is one of the biggest benefits of SDN, and it introduces agility. This means that you can deploy your network infrastructure ahead of time before you're completely sure of what kinds of applications, business models, and services it's going to be supporting. This means that when new applications emerge on the network, you can segment that network on the fly and dedicate network resources to it as you see fit in the future. This is unprecedented agility. They want to have layer 2 and layer 3 networking support in their SDN solutions because no one is going to be ripping and replacing their legacy networks with SDN anytime soon. Legacy networks are going to coexist with SDN in most enterprises for a long time. So you want to maintain that support and that compatibility between the two network environments. In terms of managing those networks, command line interface is going to be important as well. You have the ability to manage a lot of SDN through graphical user interfaces, which is something that enables you to leverage lower level network admins for engineering tasks. But those network engineers are going to want to have access to command line interface for a long time because it's the way they're used to managing the networks. It's especially the way they're used to troubleshooting them. And we've seen that enterprises are retraining their staff on SDN, learning programming skills, learning application development skills and things like that. But the CLI, the command line interface, is a core way of interacting with the network for the long term, and you're paying those network engineers for their skills with that, and chances are they're going to deliver you value through it or at some point, even if you are transitioning to more of a graphical user interface type management style. I believe that commodity switches perform as well as proprietary switches. If you look at any mainstream proprietary switch manufacturer, they're using the same commercial silicon from companies like Broadcom that commodity switch makers are using. They may make some switches with custom silicon where they develop the custom ASICs to deliver certain feature sets, but then their competitors in the proprietary switch market are delivering those same feature sets through software on Broadcom or other commercial silicon vendors' products. We've seen that commodity switch vendors, the software vendors that develop software for those commodity switches, have developed expertise in delivering those same feature sets and those same performance capabilities on commodity switches that you would see in proprietary switches. The only difference that I see for commodity switches is a cultural issue and maybe a procurement approach. Many enterprises are used to buying vertically integrated proprietary switches from companies like Cisco and Juniper and so forth, and they're not really used to acquiring a switch that maybe have a different go-to-market model, a different procurement model. and they may need some time to wrap their head around that. But in terms of performance and feature sets, they're pretty on par with the rest of the market. The earliest definition of SDN, according to the Open Networking Foundation, was that the control plane and the data plane were disaggregated, and the control plane was centralized in a controller, perhaps an appliance, and the data plane resided in all the individual forwarding devices, what were switches. But when we did research into early adopters of SDN, they rated that capability, the disaggregation of the control plane and the data plane, as the least important aspect of their SDN solutions. But what they cared about was a centralized controller. It didn't need to be an appliance, though. It can be just a function or a software element. All they want is a central point of management, programmability, and visibility. So what kind of new visibility requirements do users of SDN have? In terms of performance management, they want to have a tool that can recognize and adjust to on-demand capacity changes on the fly. And they also want new network path visualization capabilities. They want to be able to see a flow go across the network so they can monitor and troubleshoot it. And from a troubleshooting perspective, they have new reporting requirements. They want reports based on flows rather than packets. They want to be able to get reports on SDN flow activity. They want to get reports on how network conditions affect SDN flows. So if you are putting a Hadoop cluster in your environment and you are seeing all of these transactions in the Hadoop cluster manifest as flows, you can see that one of those flows is holding up and one transaction is holding up the entire Hadoop cluster, and you can troubleshoot that immediately if you see that with your new SDN visibility capabilities. SDN is truly complementary to software-defined storage and software-defined computing. When enterprises started exploring the cloud and when cloud providers started building out the cloud, software-defined technologies emerged in the compute, in the storage worlds, but no one really thought about the network for some reason. The network remained a very manual, very inagile technology. And as people started pursuing software-defined data centers and private and hybrid clouds, they realized that the network needed to be reinvented too. EMA research in the past has found that nearly half of enterprises that are doing some sort of software-defined data center technology conversion are adopting SDN. They've recognized that SDN is the final software-defined piece in the software-defined data center to introduce the same level of agility to the network that there exists in storage, in servers, and applications. Enterprises have learned from the public cloud that it's possible to get new services in 2 hours instead of 2 months. But they need to figure out how to get themselves there. They need to deploy new technologies or to introduce new ways of using their existing technologies. This means finding ways to carve out infrastructure on demand, make their infrastructure more programmable, more responsive to application developers, for instance, in a DevOps environment. This means being able to find new low-cost technologies that allow them to scale out or scale up quickly. Basically, building a private cloud that emulates the public cloud that they've been leveraging for years. SDN simplifies capacity planning by creating a more agile network. One of the most defining characteristics of SDN, according to early adopters, is a fluid network architecture. This means that you have a network that is responsive to changes in the business. It changes the way you plan your network. You used to plan your network for each new application that someone brought down from above. Now you plan your network according to what's happening with the business. Is your business growing? Then let's carve out new parts of the network to support these new business models that your growing business needs to deliver to the market. It's about building capacity ahead of time according to where you think the business is going to be, and then responding to those applications programmatically down the line. You have networks that have the ability to do more advanced traffic engineering, more application-specific network optimization programmatically, instead of relying on manual changes to the network every time an application is introduced. Instead of sending engineers out to make changes in command line interface that can take a month or 2 months, they push a button, they turn a knob, and 2 hours later the network is supporting a new application or 10,000 new customers. When we talk about a fabric in the context of SDN, it's really about being able to interact with your entire network as if it was one switch, one virtualized infrastructure. So when we asked early adopters of SDN what their number one defining characteristic of SDN was, it was a centralized controller. Not a centralized appliance, but a centralized controller, centralized point of visibility, management, and programmability into the network fabric. And when you look at the Pluribus controller, for instance, it enables a network manager to look at his entire network, whether it's dozens or hundreds of switches, as one switch device, one logical switch. And that reduces management complexity, operational costs. It really makes the network easier to manage, and operate, and troubleshoot, and reprogram to support new applications, new services, new business models. In terms of any concerns you might have about SDN overlays as opposed to other forms of SDN, overlays do deliver a lot of the value that other types of SDN offer. However, there are some challenges that will emerge. Our research has found that early adopters of SDN overlays do have concerns about control plane visibility, end-to-end visibility across physical and network elements, and end-to-end troubleshooting across physical and virtual network elements. And one key point you have to keep in mind when you're thinking about overlays is what is the condition of your existing physical network. If you have a physical infrastructure that is fraught with problems, an overlay is not going to take care of that. An overlay simplifies the process of provisioning new network connectivity to applications. It does not make your physical network function and perform better. SDN is essential in hyper-converged infrastructure. If you look at any converged infrastructure solution today, it's going to have SDN inside of it. A converged infrastructure solution creates hundreds of microservices that are interacting with each other to deliver what looks like one converged infrastructure stack. But you need an agile network, and you need network visibility at the network layer to make sure that all those microservices are working together to deliver that hyper-converged infrastructure concept to you.